welcome to this explainer. Today, we're unpacking a massive, high-stakes logistical puzzle. We're talking about international medical repatriation. If you fall critically ill abroad, how exactly does the system get you home? Well, we've got the clinical ideals on paper, but as we're going to see, the actual operational reality up in the air, it tells a totally different story. Here's our roadmap for today. We're going to breeze right through the medical transport journey, the crucial role of the contact doctor, and the step criteria. Then we'll dive into the reality of execution gaps, the big fit-to-fly challenges, and finally, how we can actually bridge these systemic failures. So, starting right off with Section 1, the medical transport journey itself. Now, on paper, this blueprint looks perfectly linear, like a well-oiled machine. It starts with Stage 1, an alarm goes off and insurance is verified. Boom, Stage 2 kicks in, and a dedicated contact doctor is assigned to manage the inpatient procedure. Then we move to Stage 3, which is all about meticulous transport planning. And the final goal? Stage 4, a successful arrival for definitive hospital treatment back home. Simple, right? Well, not quite. The absolute most vulnerable part of this whole timeline is what we call the last-mile transfer. Think about moving a critically ill patient from a ground ambulance to an aircraft out on a noisy, windy tarmac. It requires literal flawless synchronization. If the ambulance hits a bit of traffic or the flight crew is delayed for some reason, that beautiful theoretical timeline we just talked about, it completely fractures right then and there. Which brings us to Section 2, the role of the contact doctor. The contact doctor is the absolute linchpin here, bearing an immense amount of clinical responsibility. From the second they're assigned, they have to ensure the patient is getting optimal care locally. But, and this is a big but, they also have to prevent overtreatment or unnecessary exams that might complicate the transport. They're managing the length of the hospital stay, trying to keep it reasonable, all while juggling the incredibly difficult task of arranging a repatriation that makes sense both medically and financially. It is a massive balancing act. And it's the contact doctor's prescription that dictates the transport environment. Inside an air ambulance, you've got intensive care equipment just tightly packed into this tiny pressurized cabin. I mean, it is essentially a flying ICU. So matching a patient's exact specific needs to this highly restricted environment, that is quite literally a life or death decision. Okay, moving on to Section 3, defining the step criteria. To make those life or death decisions, we use the step criteria because there is a massive logistical leap depending on how stable a patient is. The lower acuity Step 1 and 2 categories, those are for stable patients who can fly on a standard commercial airline, maybe with a medical escort. But the moment a patient hits Step 3, 4, or 5, they are classified as unstable, and that mandates a private air ambulance, fully equipped with dedicated ICU-level monitoring. This official step matrix is basically the gold standard in the industry. It removes the guesswork. It forces planners to ask, does this patient need a highly specialized doctor or is a paramedic okay? What exact level of oxygen monitoring are we talking about here? It clearly categorizes the transport by required personnel and equipment, literally scaling all the way from an unescorted seat on a commercial flight up to an advanced intensive care mission. But having established this incredibly detailed, frankly ideal framework, we really have to objectively ask ourselves, does the real-world execution actually match these strict protocols? When the pressure is really on and borders are being crossed, does the system actually hold up? Let's find out in Section 4, the reality of execution gaps. To get to the truth, we dive into WCC Transport Business Intelligence data. And this isn't just theoretical data. This is logged right in the field by the medical escorts themselves. They're recording the raw, unfiltered reality. Was the patient actually in the expected condition when they were picked up? How many agonizing minutes were wasted just waiting for a ground ambulance? Was the flight logistics routing actually up to standard? This right here is exactly where the clinical ideal slams face first into logistical friction. And sadly, the data exposes some pretty severe systemic gaps. When those escorts fill out their evaluations, a distinct pattern of handoff vulnerabilities emerges. We're talking about things like missing or late route information, just poor coordination between the hospitals and the airlines, and incredibly stressful delays. In some truly alarming instances, the reports show missing onboard oxygen that forces the crew to come up with ad hoc solutions on the fly. And incredibly, there are even cases of patients being flat-out rejected by the local Emergency Medical Communication Center, the AMK, upon arrival, all just because of bad communication.
Which leads us directly into Section 5, Fit to Fly challenges.
When you hold the planned clinical procedure up against the actual reality, the gaps are just stark. The protocol strictly demands a thorough pre-visit, documenting vital signs like oxygen saturation levels, the SpO2, and checking the patient's alertness using the ACVPU scale. But the reality logged in the data, it frequently points to premature fit-to-fly assessments. And here's why that matters. If a patient is deemed fit too early, the wrong transport level might get selected. That directly leads to critical failures. Imagine arriving at the airport only to find out the airline hasn't even received the proper medical clearance to let the patient board. Ironically, while the medical tech itself is cutting edge, the digital infrastructure behind it often totally fails these frontline heroes. Escorts frequently cite really cumbersome, unuser-friendly digital systems like Medcube or AppSheet. And guys, this is not just some annoying IT glitch. It's a massive safety hazard. Just picture standing in an international airport terminal with a critically ill patient, only to realize you can't board because a clunky app dropped the patient's medical clearance. Crucial information literally falls through the cracks, things like recently undocumented surgeries or completely missing medication lists. So, how do we fix this? That's Section 6, Bridging Systemic Transport Failures. There's an evaluation quote that sums our current situation up perfectly. When the system works, it works well, but processes are not robust enough. It is so true. The individual competence of the doctors, the nurses, and the logistics planners is off the charts. When the stars align, the care is fantastic. But the overarching structural processes, they're simply too fragile to guarantee consistent safety every single time. Right now, we're relying way too heavily on the sheer heroism and adaptability of these medical crews to just overcome structural hurdles on the fly. Closing this execution gap means we absolutely have to standardize our digital workflows across the board. We need precise, consistent clinical tracking. Things like recording a patient's injury severity using the NACA score, or establishing their baseline health using the ASA score, and doing all of this long before a flight is ever even booked. Everyone involved, from the airline to the receiving hospital, has to be operating from a single, unquestionable source of truth. That is the only way to force seamless handoffs across all the different transport providers. So I'm going to leave you with this final thought to ponder. How can we optimize and redesign our digital tools and standardized planning interfaces so that a patient's chaotic reality flawlessly matches our clinical ideals, from the very first alarm all the way to the hospital bed? Because at the end of the day, the ultimate standard of care isn't just about the medicine applied, it's about the systems that deliver it. Thanks so much for joining me for this explainer, and keep questioning the systems around you.